Hello everyone, welcome to our presentation titled Analysis of Potential Evapotranspiration over Enugu State. I would like to start with introduction, and I would like to introduce evapotranspiration. Evapotranspiration, commonly abbreviated to ET, is the fluxes of evaporation from soil moisture, water, and ice, and transpiration from plants. The two processes, evaporation and transpiration, are combined in a single term called evapotranspiration. Now, under field condition, it's difficult to differentiate between evaporation and transpiration, and that's why we combine the two terms into a single term called evapotranspiration. Processes of evapotranspiration can be illustrated with the diagram on the screen. You have transpiration from trees and also transpiration from grass, and evaporation from the soil, as well as evaporation from water bodies on the earth's surface. So when you combine the transpiration from trees and grass and evaporation from the soil surfaces or any water body around, if you combine the two terms, you have the term called evapotranspiration. Evapotranspiration is the largest component of water balance, be it in the field scale, watershed scale, or even in regional scale. On a global scale, evapotranspiration may account for up to 70% of the annual precipitation. Imagine losing 70% of the annual precipitation to evapotranspiration. That's a huge loss. Therefore, quantification of evapotranspiration is very crucial. Evapotranspiration can be estimated using so many methods. We have physical estimators, and under physical estimators, you can use evaporation pans, lysimeter, Boyne ratio, etc. Another method is satellite remote sensing, then followed by emerging scientific methodologies. Under emerging scientific methodologies, you have eddy covariance, also known as eddy flux, and scintillometry. These are current methods of estimating evapotranspiration, and actually they can estimate actual evapotranspiration. Comparing these emerging scientific methodologies with physical estimators, they are far, far better than the physical estimators, in the sense that these methods, you can actually estimate your evapotranspiration remotely without going to the field every day, and they are more accurate compared to physical estimators. Recently, there is increasing need to monitor hydrological variables such as ET, especially using multi-temporal and multi-spatial sensors estimations. Satellite remote sensing techniques is one of the indirect methods for estimating evapotranspiration by predicting spatially distributed heat fluxes from point to large landscape. Therefore, this study aims to analyze potential evapotranspiration over Enugu State using meteorological data from weather stations and compare the results obtained with that from satellite remotely sensed techniques. Materials and methods. Because of availability of meteorological data, two stations were selected for this study, namely Nsukka and Enugu town, with the following longitude and latitude. Meteorological data collected were temperature, wind speed, humidity, and radiation data for 15 years, starting from 1999 to 2014. These data were collected from Nigerian Meteorological Agency, NIMET, in Lagos. The data collected were processed and ET calculated using CropWatt software. In addition to the above, necessary data for ET were downloaded from NASA and the ERA interim. The data obtained from the ERA interim were NFCDL files, which was further processed using ArcGIS 10.1 software. This is the map of our study area. The map on the bottom is the map of Nigeria, showing the location of Enugu State. Now the one on top is the map of Enugu State, showing the two locations where we collected data from. Enugu State, which is our study area, has a total area of 7,161 square kilometers, with daily mean temperature of 26.7 degrees Celsius. The state has two distinct seasons, rainy season and dry season. Results: we obtained daily and monthly potential ET for Enugu and Nsukka stations. Now looking at the table, we have the mean monthly potential ET for Enugu State with the three data sources we use, from that of NIMET, NASA, and the ERA interim. So looking at the table, you will see that on average, NIMET has the highest monthly ET with value of 4.75 millimeter per day, followed by NASA and ERA interim. The same with Nsukka station. Now looking at the month, we have January to December. You agree with me that for NIMET has the highest value in March with a value of 7.1028, and NASA for Enugu town has a highest value in January with a value of 4.22. And ERA interim has its own peak in the month of November with a value of 1.22. Now, comparing Enugu and Nsukka is similar. They have similar trend. NIMET has its peak in March and NASA its peak in January. So we can say that our evapotranspiration varies with month, both for Nsukka and Enugu station. And looking at the values, you agree with me that for Enugu and Nsukka, NIMET always have the highest value, followed by NASA and ERA interim. And the value between that of NIMET and NASA, they are much closer compared to that of ERA interim. Graphically, mean monthly ET for Enugu for 1999, you can see is exhibiting the same trend, with NIMET having the highest value, followed by NASA and the ERA interim. Now from these figures between 1999 and 2001, we can't really present all the years here, so that's why we're using just a sample, 1999 and 2011. And also we've also presented the mean averages of various sources for Enugu. So for 1999, you will see that between NASA and NIMET, the difference in ET is much more between January and maybe April, but the values tend to come close between June and October. And the difference tends to widen again after October. We can see this trend both in 1999 and 2011, and also on figure 3, which is the mean averages of the various sources. So we can say that during dry season, when we have higher values of ET, that the difference between NASA and NIMET are much more compared to that of rainy season. So it seems the values tend to come closer during rainy season than in dry season. This is something we can subject for further investigation, though it's not really within the scope of this present study. We should try to find out what is happening during the rainy season between NASA and NIMET, and also what is happening in dry season between NASA and NIMET. Error interim is quite further away, so we can't really include that. So for Nsukka station, we have similar behavior where the NASA and NIMET tend to behave well or closely in rainy season than in dry season. And also we have higher values of ET in dry season compared to rainy season. And on the average, which is the mean averages, we have similar trend. So in conclusion, we can say that potential evapotranspiration over Enugu state varies with months and seasons, with higher values in dry season than in rainy season. The evapotranspiration obtained from the three sources, NIMET, NASA, and the Enugu over Enugu state have similar trend, but vary in magnitude. Based on our statistical analysis, NIMET was most accurate, followed by NASA, though there is significant statistical difference between the three sources. However, the correlation coefficient between NIMET, ET obtained using NIMET data, and ET obtained using NASA have higher correlation coefficient value of 0.87 compared to that of NIMET and error interim that has much lower R-square value of 0.04. Therefore, we recommend that recent versions of NASA and error interim data should be tested over Enugu state to ascertain the performance of these data sources in the state. Thanks for listening.